Okay, so the first question is asking us about normal distribution. So the standard deviation is talking about how wide your graph is, so how spread out your data is. So for example, we can see this has got a mean of 2 and the data is relatively spread out, but it's quite close. This one's got a mean of 0, it's our peak point, but it's much, much closer. Okay, whereas this one has a much bigger standard deviation, it's very, very spread out. So the first one is asking us for a mean of -2. So the mean is the central point. So this one has a mean of -2. This one is 0, this is +2, and this is 0. So the only one that's got a mean of -2 is the graph C, and therefore this must be graph C. The second one is a mean of 0, and we have two different ones with a mean of 0. We've got this one and this one. Okay, so it's either graph A or graph D, but the standard deviation is 0.44, so it's just under a half. So the standard deviation, now we know that it disappears roughly after 3 standard deviations. So that would be about 1.5, which looks to be about right for this one, whereas this one disappears at 5, so it's not going to be quite right. So therefore we would like graph D. Okay, so the second question is then asking you, at an airport, the weights of suitcases in kilograms are measured and they're normally distributed. So for one of the marks here, you had to draw out your normal distribution graph as you're working. So we've got the normal distribution curve, making sure that they don't touch the axis and it looks roughly symmetrical. And you're told that it's got a mean of 20 and it's got a standard deviation of 3.5. So we've got a standard deviation of 3.5 and a mean of 20. And then we're going to be using our GDC to help us with this question. So we're finding the probability that a suitcase weighs less than 15. So if I was to mark 15 on here, it would be less than 20. So let's say here. And therefore I'm looking for the area of this section. So I'm going to go onto my GDC. I'm going to go to menu and open up a calculation page. And then we're going to go to statistics, distributions, and normal CDF. Now the lower bound is correct. We want it to be like negative infinity. Or you could change it to 0. It doesn't matter which, it won't change your answer. So they'll allow both of them because that's the lower bound. The upper bound is 15. We can see that on our shaded area. The mean is 20 and the standard deviation is 3.5. And we click OK. And that's my answer, 0.076564. And don't forget, we need to write everything to 3 significant figures or less. So therefore, my final answer is going to be, 3 significant figures or better. And therefore, my answer is 0.076564, or to 3 significant figures, 66. Or if you wanted to write it as a percentage, then it's 7.66%. So any of these options are fine. And then for the second part, this is like a reverse normal distribution question. So this time, again, we must show some working out. So we need to draw our normal distribution. Again, keeping it roughly symmetrical, making sure it doesn't cross the axis. It's the same question, so we've got a mean of 20 and our standard deviation of 3.5. And it says that any suitcase that weighs more than K is considered excess baggage, and 19.6 are considered the excess baggage. So that means that if the area is more than, it's somewhere up here, and the actual area is 19.6%, okay, or 0.196 as a decimal. But don't forget, when we do an inverse normal on the calculator, it can only accept areas to the left. It's used to doing less than, so we're going to have to take that into account. So we do menu. Before we do that, actually, just to make it even simpler, we can do 1 minus the 0.196. Okay, so now we can see that it's an area of 80.4 that we're needing to put in. So it's 80.4% as the area that we're needing. So we can go into menu, probability, statistics, distributions, and inverse normal, and it will ask us for the area. So 0.804, that's 80.4 as a percentage, or you can write 80.4 with the percent sign. The mean is 20, and the standard deviation is 3.5, and that gives me an answer of 22.996. And then, same as last time, you should round your answer. So 22.996 to 3 significant figures becomes 23 kilograms. Okay, so 3 significant figures or better.